All right, we have reference angles, and we talked about those definitions of trig functions of any angle. And we're going to see why why we need reference angles technically to create those definitions. So when we talk about a point P of xy that's not on the unit circle and really not in quadrant 1, things get a little dicey. Okay, so let's imagine we have a point P of xy over in quadrant 2. Okay, just for an example. Okay, when we talk about this point, right, we could form an angle and we could say, point P is on the terminal side of angle theta. Okay, that's just fine. Now, when we work with this, if we need to talk about the trig functions corresponding to this point at all, then what we said before is, we need to drop an altitude and then we can kind of see a right triangle forming. And if it was a right triangle, we'd have a side length x going horizontally, y going vertically, and then the hypotenuse would be r is equal to square root of x squared plus y squared by the Pythagorean theorem. Okay, but technically, if we want to do anything with trig functions, right, we would need this angle down here in red, right? What is that angle? We just talked about reference angles, right? This is the reference angle, okay? So technically, whenever we are evaluating the trig functions of any angle, we can use a triangular approach. We just have to evaluate the trigonometric functions for theta prime, and then again, theta prime will allow us to, I guess, theta prime is our reference angle, and that'll allow us to get the trig ratios, but remember that would be in the context of a triangle, which has all positive sides. So typically when we evaluate trig functions using reference angles, we would need to include plus or minus depending on the quadrant. Okay, so let's see this in action. Okay, I'll do 2 examples and then you get to do the last one. Okay, let's use sine or find sine of 7 pi over 6, negative 7 pi over 6 using reference angles. There are other ways to do this. I fully acknowledge that. Okay, so here's the idea. Oop, I want black. All right, sorry about that. Here we go. So I'm just going to do a little sketch. 7 pi over 6, okay, here is pi negative, and then 7 pi over 6 would go a little bit further, right? So that is our angle theta. And I know, let's see, this would be our reference angle theta prime, okay? And I might remember from the unit circle, okay, if you have that handy, that this point p of xy would be negative square root of 3 over 2 comma 1/2. Okay, and so you could just say, oh, it's going to be 1/2. Yeah, that's not the point. So let's just pretend we don't know that. Okay, now if I wanted to evaluate this, remember I could see a little triangle here. Okay, and I could say, well, according to the above property, right, sine of whatever this is going to be equal to sine of theta prime. I just need to include the appropriate plus or minus. So this is going to be sine of the reference angle, which you can calculate it. It's going to be pi over 6. Okay, so to find it, you might have to acknowledge that the geometry here is 7 pi over 6 plus or minus theta, right? Because you kind of have to go backwards, is going to be pi, and then you can move things over, and you end up getting pi over 6. Okay. I digress. I'll just write that down here. Actually, let's undo. Okay. I don't know what's going on. Here we go. Undo, 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 undo. Okay. And we'll just move that. All right. So now I'm ready to evaluate it, but I have to keep in mind it says depending on the quadrant, right? So the quadrant, in this quadrant, sine is positive, so I'm going to use positive. And now I just have to evaluate sine of pi over 6, and that maybe you've just remembered your first quadrant a little bit better than the rest, but sine of pi over 6 would be 1/2. Okay. So again, same thing as what the unit circle would give us, but just using reference angles. Similarly, for the next one, tangent, I start with a little sketch. 120 is over here. Okay, 120 degrees. And then my reference angle here would be 60 degrees. Okay, so what I can do for tangent, right, according to this, it says it's going to be the trig function evaluated at the reference angle, so theta prime, 60 degrees, and then I just need to include plus or minus. Okay, in quadrant 2, tangent is negative, so I need to say that this is actually equal to whatever the negative tangent of 60 degrees is. Okay, and again, the kind of upshot of this is if you need to commit any quadrant to memory, maybe just the first quadrant, because then you can always use reference angles thereafter. Okay, and tangent of 60 degrees, if you look up that on the unit circle, the y coordinate is square root of 3 over 2. X coordinate is 1/2. And so then you can go forth and say that this is negative square root of 3. Okay. So again, you might think it's a little lengthy. It could be shorter depending on the case. Okay. Now the last one that I want you to try and then watch the solution is this next one, secant of 15 pi over 4. Resume the video when you're ready to see the solution. And here's the solution. So again, I kind of said 15 pi over 4 is equal to 8 pi over 4 plus 7 pi over 4. So that means it does one full rotation counterclockwise and then 7 pi over 4 more, putting us in quadrant 4 for the terminal side. And then the reference angle would just be the remaining part up to the x-axis, which would be pi over 4. Okay, so that's my reference angle. So then I move forward. I said, okay, secant of 15 pi over 4 is the same as secant of pi over 4. Positive because secant is positive in quadrant 4. Okay, and then the rest of this is just evaluation. So I changed it to the reciprocal function, substituted in root 2 over 2 for cosine pi over 4, simplified and got it. Okay, so again, this one I see the benefit of using reference angles. Just because who has secant of 15 pi over 4 memorized, and it's easier geometrically, perhaps. But otherwise, remember, this is just another tool in our already quite large toolkit for trig functions.